All right, so now we're going to be talking about adding and subtracting matrices. But let's go over a few things. Matrices they are used to organize data. Capital letters are used to name matrices. So, like A, B, C, but capital A, capital B, capital C. And they're classified by their size. The number of rows, we say by the number of columns. A matrix with m rows and n columns is called an m by n matrix. The number of rows always comes first. And then a square matrix is a matrix with the same number of rows and columns. A row matrix, or a row vector, we say, is a matrix containing only one row. And then a column matrix or column vector is a matrix of only one column. So let me give you a few examples here. So let's say we have a matrix, we call it A, and then we see -3, 5, 2, 0, 5, -1. All right, we call it matrix A, right? And then to describe it, we would say, since it has 3 rows, we would say it's a 3 by, it has 2 columns, so 2, it's a 3 by 2 matrix is what we would call this. And then let's say we have matrix B, where we have 0.5, 0, -4, 8, 5.1, 0, 0.9, -3, 5. All right, we would say this has 3 rows, 3 columns, so we would call this a 3 by 3 matrix. And yes, it's a square matrix. As far as the row vector, it would look something like this. Excuse me. This would be called a row vector, and its size would be a 1 by 3. A column vector will look something like this. Has 3 rows and 1 column, so we would call it a 3 by 1 matrix. So let's talk about matrix equality real quick. Two matrices are equal if they are the same size and if each pair of corresponding elements are equal. So, for example, if I give you that 2, 1, 3, -5, and then I give you 1, 2, -5, 3, while they both have the same numbers in, they're not equal because these elements are not corresponding to one another, meaning the first row, first column of this second matrix is not 2, it's 1. So these are said to not be equal. All right. But let's say we do have 2 matrices that are equal. I tell you they are. Then from here, we can define some things. Number 1, we can say x is 2. We know that y is 1. P is -1 and Q is 0. Now, if we have XY and we want to say that it's equal to 1, -3, 0, this can never be because the sizes are not the same, right? So one of the elements is that it has to be the same size to be equal. So not equal because different sizes. Okay? So let's get to the adding part. When we add matrices, the sum of two M by N matrices, let's say they're called X and Y, is the M by N matrix X plus Y, in which each element is the sum of the corresponding elements of X and Y. And that may sound a little complicated, so let's just look at an example. Let's say, for example, we want to add 5, -6, 8, 9 plus -4, 6, 8, -3. Then the first row, first column element of the first matrix, 5, has to be added to the first row, first column element, -4. And then we have the second row, first column, 8 plus 8. And then -6 plus 6. And then 9 plus -3. That's pretty much what this is saying. So our result would be 1, 16, 0, 6. This is the sum of these two matrices being added together. If I give you matrix A, 5, -8, 6, 2, and ask you to add it to matrix B, which says then you need to say this is not possible because matrix A and matrix B are two different sizes. Okay, they're two different sizes. Now, when we subtract matrices, we're going to follow the same rule. They have to be the same size. Okay, I'm not going to write all that out. I just told you, right? So here, if we have 8, 6, -4, and then -2, 7, 5, minus 3, 5, -8, -4, 2, and 9. If we're to subtract these, then we have to follow that same, the corresponding elements. So this would be, for instance, the first row, first column element of the first matrix, which is 8, minus the first row, first column element of the matrix 2, 3. That's how we would get that result. For the second, we would take 6, subtract 5. For the next one, negative 4 minus negative 8. Don't get tripped up by that. We know 2 negatives just means positive. And then we would keep going, right? So this one would become negative 2 minus negative 4, 7 minus 2, 5 minus 9, for a result of 5, 1, 4, 2, 5, and negative 4. That would be the result here.